So this question comes from the 2013 exam, and it is an example of a rate in, rate out. And we get to use our calculator, so woohoo! So the question reads, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 90 plus 45 times the cosine of t squared divided by 18, where t is measured in hours and when t greater than or equal to 0 but less than or equal to 8, and at the beginning of the workday t equals 0, the plant has 500 tons of unprocessed gravel during the hours of operation. The plant processes gravel at a constant rate of 100 tons per hour. So the first question is, find g prime of 5. Using correct units, interpret your answer in the context of the problem. So, since we can't take this by hand, we'll just have to use our calculator to figure it out. So, on the calculator right here, I have it already graphed. As you can see, there is no graph. So, we're just going to go to calculate. And we're just going to find the derivative of this problem at x equals 5. So g prime of 5 equals negative 24.587. And so how we interpret this is that we're going to use this as a rate. So the amount of unprocessed gravel is decreasing, since our value here turns out to be negative, by negative 24.587 tons per hour. So part B says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So on this workday, well, the question is, we have to find the total amount of unprocessed gravel during the hours of operation on the workday, so therefore we will have to do an integral between 0 to 8 of g of t dt. I know that's a weird looking g. I'll fix that. There we go. It looks normal. So we can use our handy dandy calculator, and we'll just go in here and find this integral. So the calculator is going to think. And so we get 825.551 tons of unprocessed gravel. So part C is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours. Show the work that leads to your answer. So at t equals 5 hours, we have to see if the amount of unprocessed gravel at the plant is increasing or decreasing. So therefore, we just have to plug in 5 for g of t. And so g of 5 equals 90 plus 45 times the cosine of 5 squared divided by 18. So I don't know what the answer is by hand, but we have our calculator, and so we can just plug this in. 90 plus 45 times the cosine of 5 squared divided by 18. which equals 98.141 rounded. Excuse me. But we need to see if the amount of unprocessed gravel at the plant is increasing or decreasing at 5 hours. So it says here, during the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. And since G of 5 equals 98.141, we can say that 98.41 is less than 100. Since the plant processes gravel at a constant rate of 100 tons per hour, and therefore the amount of unprocessed gravel at the plant is decreasing at T equals 5 hours. So part D, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. So V prime of T. So we have to find, so we're going to have to find what T equals in order for V prime of T to equal 0. But let's do a little table here of our values. So we have 0. So at T equals 0, the plant has 500 tons of unprocessed gravel. So we already know that. And at T equals 8, we still have to figure that one out. So we would just have to set G of T equals 0 minus 100. And the only reason why we put minus 100 is that the plant processes gravel at a constant rate of 100 tons per hour. So that 100 is being lost from the total of unprocessed gravel. So we would do 100 minus 90 plus 45 times the cosine of T squared divided by 18. So this would be 10 times 45 times the cosine of T squared divided by 18. So therefore T will equal 4.923. So we can add that value to our table. And so V of T minus V of 0 equals from 0 to 2 times T over minus G of X minus 100 dx. And so we can just plug all of this into our calculator. So when you plug in 8 for T, we will have 525.551. And we plug in 4.923 for 8, then we will get 635.376. So therefore this right here will be our maximum.